Welcome back, everyone. I am absolutely thrilled to guide you through today's explainer. We're going to take a real deep dive into section 10.4 of our textbook, Dependable Processes. As a software engineering student, you spend so much time thinking about the code itself, right? How to write it, compile it, test it. But today, we're zooming out. We're going to look at the environment in which that code is actually born. We're going to explore why the discipline, the standards, and the overall processes of the team building the software are quite literally just as important as the logic of the code itself.
Here is a quick look at our agenda for today. We'll start with an introduction to dependable processes, move into proving it to regulators, look at the attributes of a dependable process, discuss redundancy and diversity, tackle agile versus dependable systems, and wrap it all up with a summary and exam focus.
All right, Section 1, Introduction to Dependable Processes, Moving Beyond the Code.
Okay, let's dive into this. As we shift our focus from the software code itself over to the process of building it, we hit the core philosophical hook of this entire lecture. A good software process is highly likely to lead to delivered software that simply contains fewer errors. It makes sense, right? If you design a workflow that's specifically geared toward avoiding the introduction of errors in the first place and detecting them super fast when they inevitably do slip in, well, your final product will naturally be far less likely to fail out in the real world. Simply put, good process inherently yields better software.
Section 2, Proving it to Regulators, When Promises Aren't Enough.
So, why does process matter so much? Because out in the real world, especially for critical systems, think aviation, nuclear power, medical devices, you can't just look a safety regulator in the eye and say, hey, trust us, we tested it. That doesn't fly. You actually have to present a heavily documented model of your process and provide concrete evidence that your team followed it to the letter. The absolute first non-negotiable requirement here is that the process must be explicitly defined. Let's break that down. An explicitly defined process has a formalized, written process model that actually drives the software production. But it doesn't stop there. You have to collect data during the whole development cycle, things like logs, review sign-offs, test coverage metrics, data that unequivocally proves to an outside regulator that your team actually followed the defined model. Because honestly, a plan on paper means absolutely nothing without the data to back it up.
And that brings us to the second non-negotiable requirement. The process must be repeatable. What this means is that your process cannot rely on one single genius developer's personal judgment or their highly unique way of doing things. You see, critical systems often take years to develop. Your team will inevitably change over that time. People get promoted, they move on, they retire. A repeatable process survives all of those team changes. It can be enacted identically across completely different projects and by entirely different team members. So just a quick micro recap here. To satisfy those regulators, your process has to be explicitly defined with the hard data to prove it, and it must be repeatable, regardless of who happens to be sitting at the keyboard on any given day.
Section 3, Attributes of a Dependable Process, the 5 key characteristics.
So, if we know a process needs to be defined and repeatable, what specific characteristics actually make it dependable? Let's methodically break down these 5 key pillars. First up, auditable. This means the process is entirely understandable by people completely outside the project, like those regulatory auditors we mentioned, who can pop in and check that standards are being followed. Second, diverse. A dependable process includes redundant and diverse verification activities. It never relies on just one single way of checking things. Third is documentable. It has a defined process model that continuously churns out records and evidence. Fourth, robust. The process can actually recover from the failures of individual activities without the whole project collapsing. And finally, standardized. It follows consistent, repeatable industry practices. And hey, please note that South African English spelling there with an S, standardized. These 5 attributes right here are the absolute pillars of process dependability.
Section 4, Redundancy and Diversity. Applying system concepts to process.
So, to quickly recap, our process has to be auditable, diverse, documentable, robust, and standardized. We just established that a dependable process must be diverse. Now, here is exactly how we apply that concept to our workflows. And this brilliantly illustrates that diversity. On the left side, we have manual program inspections. This is human beings sitting down, reading code, actively looking for logic flaws based on their own unique human experience. On the right, we have automated static analysis. These are software tools mathematically parsing the source code to find anomalies. We have 2 completely diverse activities here, right? One human-led, one machine-led, but both are aiming for the exact same goal, finding bugs. Using both creates a highly redundant, incredibly strong safety net. If a human misses a tricky flaw, the automated tool might just catch it, and vice versa. Oh, and by the way, make sure to use the spelling PROGRAMME when you're writing your exams.
Section 5. Agile versus dependable systems, the modern industry conflict.
Now, this brings us to a massive real-world conflict in our industry. How exactly does this rigid, heavily documented process fit into the fast-paced, highly flexible world of Agile development? Let's put you directly in the driver's seat for a second. Imagine you are the lead engineer developing a brand new, mission-critical student records and academic transcript system for a huge university campus right here in Centurion. You've got hundreds of developers working on it. If the wrong version of a database component accidentally gets uploaded, you could literally corrupt the academic histories of thousands of students. In a fast-paced, agile environment, how on earth do you prevent this kind of catastrophe?
The answer is strict configuration management. By definition, configuration management is the process of managing a changing software system, ensuring that all your developers can access the project code in a highly controlled way. It manages your versions, tracks all changes, and controls the final system build. For our hypothetical Centurion students, configuration management is the ultimate safety net. It ensures that the exact, fully tested, and approved version of a component is the one that actually gets compiled into the final release, preventing any corrupted or untested code from slipping through and destroying those records.
But herein lies the major tension. On the left, Agile methods love to minimize documentation, and again, note the S in minimize there. They prefer to co-develop requirements entirely on the fly as the system is being built. For Agile, it's all about speed and iteration. But on the right, regulators and safety-critical systems fundamentally hate this approach. They demand heavy, upfront analysis to discover any conflicts early on, and they require massive amounts of documentation for their certification processes. So, as you can see, a pure Agile approach struggles deeply to meet the strict, evidence-based demands of those regulators.
So, how do we actually solve this? Well, the industry is increasingly relying on a hybrid solution. We don't just throw Agile away completely. No. Instead, we combine Agile's excellent test-first, iterative development practices with the strict documentation, upfront modeling, spelled with a double L by the way, and the formal change analysis of traditional plan-based methods. This approach gives us the best of both worlds. It totally satisfies the regulator's need for an auditable, explicitly defined process while still maintaining as much developer flexibility as humanly possible. So, to give you a quick micro-recap, pure Agile lacks the documentation regulators need, so we merge it with plan-based strictness to create a highly dependable hybrid process.
Section 6. Summary and Exam Focus. What you need to know. All right, let's lock in this knowledge for your test preparation. So, the absolutely crucial point is this. For your exams, you must be able to list and define the 5 attributes of a dependable process: auditable, diverse, documentable, robust, and standardized. You also need to know the 2 non-negotiable requirements for regulators. The process must be explicitly defined and repeatable. And finally, you must be able to clearly explain the tension between Agile and dependable systems, specifically why pure Agile struggles with regulatory compliance due to its inherent lack of upfront analysis and heavy documentation. And please, I can't stress this enough, remember to use your correct South African English spellings: program, standardized, modeling, and minimize.
I'll leave you with this final concluding thought. Great software isn't just about the code. It is about the discipline and the standards of the team building it. As you step out into your careers and start building the systems that essentially run our modern world, you have to ask yourself, are you just writing code or are you engineering trust? Next time, we're going to build on this solid foundation by looking at formal methods and how strict mathematical models can push our dependability even farther. Thank you so much for your time. Study hard, and I will see you in the next explainer.